Hello everyone, this is Shravya. I'm currently pursuing my BE third year in Sri Venkateswara College of Engineering. In this video, I'm going to discuss about the research paper based on the anonymous communication in computer networks. Here, first, we have abstract. In that, anonymous communication aim to preserve communication privacy within the shared public network environment. It can provide security well beyond communications are largely originated from comms to seminal approaches. Here we have MixNet and DCNet. In this paper, we, we need to present an overview of the research in this field. We start with the basic definitions of anonymous communications. We then describe the cryptographic primitives, the network protocols, and same of the representative anonymous communication systems. We also describe verifiable mixnets and their applications to electronic voting. Finally, we briefly cite some other anonymous systems. Next, we have introduction. In this, the rapid growth of internet applications has made communication privacy an increasingly important security requirement. While end-to-end encryption can protect the data content of communications from adversarial access, it does not conceal all the relevant information that two users are communicating. Adversaries can still learn significant information about the traffic carried on the network and the physical world entities, such as the networks of the sender and the receiver of the network. Next, we have terminology. In this section, we will introduce some definitions of anonymous communications. Means a comprehensive reference on the definitions has been defined by Fitzman and Hansen, which has been updated multiple times. This most recent version was developed in 2008. Next, we have mixnet based schemes. In these cryptographic primitives for anonymous communications, in this section, we will outline some cryptographic primitives that can be used to provide source privacy. Next, we have past 2 decades in that originated largely from Commerce Mixnet and DCNet. A number of anonymous communication protocols have been developed. They can largely be divided into MixNet-based systems and DCNet-based systems. All secure mix systems are based on seminal work as a mean of sender anonymity. The MixNet family protocols use a set of mix servers that mix the received packets to make the communication paths, including those of the sender and the recipient, ambiguous. It is largely originated from DCNet of number of anonymous communication protocols, and it can be largely divided into 2 systems. Next, we have DCNet systems. Means this DCNet systems was first proposed by COM in 21st century. It allows participants to send assumption of a reliable broadcast networks. The anonymity of the senders is proved to be unconditional. DCNet is a secure multi-party computation protocol. It provides provable sender and receiver anonymity without relying on a trusted third party. A very attractive feature of the basic DCNet is its non-interactivity. This means that at any party in the network routing-based techniques. In this section, we will also describe some routing-based anonymous communication schemes. Next, we have peer-to-peer networks. In this section, we briefly describe 2 representative peer-to-peer anonymous communication systems. COM pointed out that if each participant in the mix acts as a mix for others, then the overall security can be improved. This has been implemented in both systems. Verifiable mixnets are specially designed mixnets which are robust against subverted servers from denying service. The correct functioning of any given mix can be verified with a proof of its correct functions. The primary motivation of verifiable mixnets is to enhance the security of mix-based election protocols, where both universal verifiable of vote delivery and privacy are of great importance. Most of the design verifiable mixnets and applications to e-voting of verifiable mix is implemented through a cascade of mixes. Next, we have the other systems in this research paper. A number of other systems have also been proposed through the years. P5 was proposed by Sherwood et al. In 2022 for anonymous communication over the internet. P5 stands for Peer-to-Peer Personal Privacy Protocol. It uses broadcast trees to achieve anonymity. Then this P5 provides individual participants a trade-off between degree of anonymity and communication efficiency, which can be used to scalably implement large anonymous groups. P5 creates a broadcast hierarchy. We came to conclude this research paper. In this survey, we reviewed the major techniques in the field of anonymous communications. We focused on cryptographic primitives, mixed-net-based systems, DCNet-based systems, network routing-based systems, and peer-to-peer networks. We also briefly described the applications of verifiable mixnets and applications to electronic voting. Through this research paper in anonymous communications has been going on extensively for nearly 3 decades, but it is also still a very new and active research area. We have the acknowledgements of this research paper. The work of GOWU is supported in part by NSF grants CNS 0422762. The CNS 0626240 and CFF 0839289 and CNS 0948184. This network is worked is JNREN is supported in part by NSF grants CNS 0845812, CNS 0848569 and CNS 0716039. We have the references here. DCOM untraceable electronic mail return addresses and digital pseudonymous communications of the ACM in 1981. Fitzman, M. and Hansen anonymity, unlinkability, unobservability, pseudomity, and identity management a proposal or reversed ETAL dot how to leak a secret and DCOM E. Van Hysed group signatures in advances in cryptology. Eurocrypt lecturer notes in computer science. LTP Pedersen new group signature schemes in advances in cryptology. Eurocrypt lecturer notes in computer science. LTP Pedersen on the efficiency of group signatures providing information theoretic anonymity in advances. JL Kempsen efficient and generalized group signatures in advances in cryptology, Eurocryptology lecturer notes in computer science. JL Kemensin, MA Stadler efficient group signature schemes for large groups in advancing cryptology. Thank you.